Hello everyone, good day. My name is Frank Ebelidike and I'm a member of the Tech Rangers team. And today I'll be presenting our project which is titled Bridging the Standardization Gap in Next Generation Telecommunication. Now, our solution is a dual layered agent mechanism that starts with the agentic RAG chat system for telecommunication standards training and then the multi-agent mechanism for gap detection and recommendation. So to actually set this up, we installed the necessary libraries. Then we connected to our knowledge base, which contains ITU's standards documents that were preprocessed. Then we connected to a specialized LLM, which we developed using continued pre-trained fine-tuning on ITU-T text. Then we set up the retriever for our knowledge base. Then we defined the tools that the agent would use. Then we defined our agent and gave it the necessary tools. Then finally, we created a chat interface so that we can send queries to our chat agent. So looking at the responses here, the first question that we asked it was, what are the critical KPI for major events? Now, the RAG system identifies that this answer must be from this ITUT standards document. Then the system loads the document using this tool. Then it uses vector search to locate the relevant clauses. So as we can see, it gets three relevant clauses. Then it uses the text extractor to extract relevant text from these clauses. Then it uses this summarizer to summarize the text that it had gotten based from that clauses. And then finally, we can see that it's validating this information, and then it attaches the relevant sources where this information was gotten from. Then it gives the final answer to the user's question in bullet point, as well as the relevant data sources where this information were gotten from. Then next, we asked it another question: summarize the security challenges for IoT device in a cellular network. Now, to tackle this question properly, this agent understands that it needs to pull multiple sources of IoT specific threats in cellular environment as it relates to ITU standards. And then it summarizes the content it had gotten from those sources. And finally, it gives a final answer to the user, which is this. So IoT devices and cellular networks are threatened by RF level DOS, and so on and so forth. Now, by leveraging this standardization tool, innovators working in 5G or 6G and autonomous networks can reduce barriers to entry. They can accelerate their development and also ensure that whatever it is that they are building is compliant with ITUT standards. Now, moving on to the second component of this solution, which is the multi-agent mechanism for gap detection and recommendation. We're making use of 5 agents, which is the cartographer, the analyst, the hypothesizer, the verifier, and the synthesizer. And all of these agents works in sync to be able to identify gaps and then give recommendations to the user. So over here, we set up our environment, we connect to our knowledge base, and we set up shared resources, which is the large language model. And then we also define the core tools that all of these agents will be using. So over here, we developed the first agent, which is the cartographer. And the cartographer is responsible for performing topic modeling and summarization of users' inputs. And then next, we developed the second agent, which is the analyst. And this agent is responsible for conducting a detailed comparative analysis of selected topics to uncover inconsistencies, outdated standards, or underexplored areas. Then we developed the third agent, which is the hypothesizer. And this agent is responsible for transforming analytical findings into clear, testable hypotheses by generating questions about potential gaps. Then moving on to the next agent, which is the verifier. Now, this agent is responsible for testing each of these hypotheses through targeted semantic search and gathering evidences in order to confirm whether these hypotheses are either true or they are false. And then lastly, we have the synthesizer, and this agent is responsible for compiling all of these findings into a structured report where it mentions the gaps, the supporting evidences, potential implications, and then gives recommendations to the user. Finally, we then orchestrate the multi-agent workflow for all of these agents and how each of their output will be given as input to the next agent. Then finally, we set up an interface which we use to interact with this agent. And over here, we're asking it our first question: are spectrum allocation guidelines adaptable to the regulatory and economic constraints in African nations? So in this question, we basically want to examine whether the current spectrum allocation policies can be flexibly adjusted to accommodate the unique regulatory and then economic challenges faced by African countries. And so the process begins with the cartographer, which maps the landscape of spectrum allocation in Africa by extracting key themes from the knowledge base. And as you can see, these are the themes it extracted: verified national regulatory capacities, cost recovery versus universal service goals, regional harmonization efforts, and so on and so forth. And then this output is then given to the analyst, and the analyst conducts a comparative analysis of contrasting ITUT's model with real-world data from African countries. So we can see that the analysis uncovers some truths such as Nigeria's high upfront fees delays network rollout. We can also see that Kenya successful dynamic licensing also increases rural coverage. Then moving on, this output is then given to the hypothesizer, and the hypothesizer then translates these gaps into testable claims by proposing three core hypotheses, which are one size fits all licensing ignores local fiscal constraints, lack of technical expertise in NRAs hinders flexible policy enactment, and then overemphasis on revenue generation reduces incentives for universal service. This hypothesis link the policy design flow to implementation failures that shows areas that basically need to be improved. Then the verifier takes this output and then validates this hypothesis against empirical evidences. Now, finally, this is fed to the synthesizer, and then the synthesizer then creates a gap report out of all these findings. Now, this is a gap report, and if we study this carefully, you will see that each gap is linked to a supporting evidences, its implication, and then recommendation. So in conclusion, this multi-agent mechanism for gap detection and recommendation helps to accelerate policy diagnosis and also help innovators to remain standard compliant even as they build their products. Thank you very much.